show that when you take tan inverse of x and tan inverse of 1 over x, what do you get? Well, this is defined as theta. We've just shown that this is pi on 2 minus theta. Okay, so that's where you get your pi on 2 as required because the theta's cancel. Okay, last little piece. It says, use the fact that tan inverse is odd to find out what happens when you don't think about this anymore. When you go for x is less than 0. Okay, you go for x is less than 0. How do we approach this? How do you approach it? It's not that complicated if you think about the way all of this is going to work. Tan inverse is odd, right? So what does that mean about this? It is also odd. On what grounds would you argue that? Inside function's odd, outside function's odd, so the whole lot is odd. Okay? So that means that in order to consider what's happening to this thing when x is less than 0, right? You can slap minus signs on everything. You can say, what's happening to this guy? Right? Negative. And this is going to be 1 over negative x. Okay, what's going to be happening to him? Well, because we just demonstrated that these are both odd, okay, that's going to be negative tan, and that's going to be, negative tan of the reciprocal. Okay, because they're both odd, I can take the minus signs out as tan inverse x and tan inverse 1 on x are odd. Okay. Now what's this thing equal to? You take your factor of minus 1 out, and then you've got what you showed in part C. There, right? It's negative pi on 2. So therefore, what does, where am I looking? What does this graph, y equals this, what would it look like for all values of x? No, stay with red. What would it look like? What's it equal to a 0? When x equals 0? Undefined, because you have a division by 0 there, okay? But for x is positive, right? You've got pi on 2. Okay? For x is negative, you've got negative pi on 2. And guess what? I know we don't usually think about it this way, but that is an odd function, because the sum of two odd functions will be another odd function. So there you go.